This is 4-7 CPCTC. In the warm-up, if triangle ABC is congruent to triangle DEF, then angle A would be congruent to, since A matches D, angle A would be congruent to angle D. And segment BC would be congruent to EF. What's the distance between these? You're going to need to use a distance formula. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So x1, y1, x2, y2. So I'm going to do square root of -1 minus 3 squared plus -1 minus 4 squared. D equals the square root of -4 squared plus -5 squared. So D equals the square root of 16 plus 25. D is the square root of 41. Use a diagram at the right. If angle 1 is congruent to angle 2, what's the reason that they're parallel? Well, lines A and B are parallel by the converse of, and since these are alternate on the transversal and inside the parallel lines, that would be on alternate interior. List methods we can prove two triangles are congruent. So we can say that all corresponding angles and sides are congruent. Or we can use the shortcuts that we've had so far, SSS, SAS, ASA, AAS, HL. We can use CPCTC to justify that corresponding parts of two triangles are congruent if the two triangles are congruent. So once we know that two triangles are congruent, so say I tell you that triangle ABC is congruent to triangle DEF by side, side, side. If I say that to you, these are congruent. Triangle ABC is congruent to triangle DEF by side, side, side. Now, I can say anything I want after that. So now I can say like angle A is congruent to angle D, because I already know the triangles are congruent. So I would say angle A is congruent to angle D by CPCTC, because the corresponding parts of the congruent triangles must be congruent. Let's take a look at example 1. A and B are on the edges of a ravine. What is AB? So I'm looking for AB. AB is looking like it matches up with 18 miles, but we have to know for sure that these are congruent triangles first. So let's look at and see what I already know. Well, I know that this, we'll call this C in the middle. AC is congruent to, none of these are marked. Ugh. Okay, EC. So they're both 10. So that tells me they're both 10 miles, right? And I know that the 15 miles is congruent to this 15 miles. And I also am seeing a vertical angle in here. So these are congruent by vertical angles. I'm labeling that because everything else was given so far. So those are congruent by vertical angles. And so now that I know that the triangles are congruent, so the triangles are congruent by SAS. And you can see that S is right here, A in the middle, S, side, angle, side. Same thing over here, side, angle, side. So the triangles are congruent. Now everything about these triangles are congruent. So I know that this third side must be equal to the other third side. So therefore AB is equal to 18 miles. And in order to use CPCTC, I have to first state what the triangles are congruent by. Now you try. To design a bridge across a canyon, you need to find the distance from A to B. Locate C, D, and E as shown in the figure. If DE is 600 feet, what is AB? Now we can kind of assume it's going to be 600 feet, but we have to go through the actual process. So I have one side congruent to another side because they're both 500 feet. I have a right angle congruent to a right angle, and I also have vertical angles in here. So I know that these triangles are congruent by ASA. So you can see that right here, the ASA. Now that I know the triangles are congruent, I can say that side DE is congruent to side AB by CPCTC. And so I know that the length of, sorry, not DE, the length of AB is equal to 600 feet. So once the triangles are congruent, everything about them is congruent. Okay, let's take a look at this. So AB is congruent to DC. Well, I already see that in my given. So AB, and it's marked already on my picture, so I'm just checking that. Now angle ABC, this large angle, is congruent to angle DCB, the other large angle over there, and that's given. And I'm seeing a reflexive property of congruence as my reasoning, so I'm noticing that this line, BC, on one of the triangles is congruent to the BC on the other triangle. And now I can say the triangles are congruent. This SAS means that some pairs of triangles were congruent. So because of SAS, we have triangle ABC congruent to triangle DCB. And now I can prove that anything else is congruent. So in this case, they're asking me to prove angle A is congruent to angle D by CPCTC. Okay, on the now you try, so we have our first given YW bisects XZ, so I know that's given, and let me look at that. So YW is bisecting XZ. So I know that it's going to create two congruent parts. So I know that XW is going to be congruent to WZ. Definition of bisector. We also know that XY is congruent to YZ because it was given. XY is congruent to YZ because it was given. And YW is congruent to YW because of the reflexive property. So now I know that these triangles are congruent by SSS. And so to prove that the angles are congruent, I can prove anything's congruent after by CPCTC. Okay, example 3. Let's take a look at what's happening here. So first thing they say is angle N is congruent to angle P. Well, that was given. Let me mark that on my image. Angle N is congruent to angle P. Angle NOM is congruent to angle PMO. And that's actually because of this is kind of backwards here. That's because of alternate interior angles. Alternate interior angle theorem. Since those lines were parallel to each other, NO is parallel to MP. That's what made the alternate interior angles. So in this part was given. So really those should have been reversed. And then reflexive properties. So something that I see that's congruent to itself would be this middle line. I don't know why I did 2 dashes. You only need 1. But OM is congruent to OM. And now I can say the triangles are congruent to each other by AAS. And if you want to show which steps that would be, it would be steps 1 was one of the angles, step 2 was another angle, and the S came from step 4. And now we can say anything is congruent to anything else by CPCTC. So I can say like angle NMO is congruent to angle P. NMO is congruent to POM by CPCTC. And I know the lines are parallel by a converse theorem. So converse of, so these are my angles, converse of alternate interior angle theorem. Okay, for the now you try. J is the midpoint of KM and NL. KM and NL. Well, that's going to be given, but I can tell you right now that they gave us that because they're saying that that's congruent to that and this is congruent to this. So I'm definitely going to have to write some stuff about that. Oops, sorry, 1 and 3 are given. So if J is the midpoint of KM, that means that KJ is congruent to JM. And if J is the midpoint of NL, then NJ is congruent to JL by the definition of midpoint. Then we have angle KJL. KJL is congruent to angle MJN. What kind of angles are those? Why would those be congruent? They're vertical angles. So this is vertical angle theorem. Okay, and my next reason is SAS. That's a triangle congruent statement. So I'm saying that two triangles are congruent to each other. I'm looking at this top triangle and this bottom one. So let's mark it up correctly here. We've got triangle KJL congruent to triangle MJN by SAS for steps 2, 4, and 5. And then angle LKJ. So now that they're congruent, they're saying something else here. LKJ, give that 2 congruent marks, is congruent to NMJ. And that would be by CPCTC, since we're saying something's congruent after the triangle congruent statement. And then converse of alternate interior angles theorem, converse of something is proving lines parallel. And this is the last step, the prove. KL is parallel to MN. Example 4, using CPCTC in the coordinate plane. So we are given that A is 2, 3. I'm just going to plot all these. I'm going to pause it and plot it so the video is not too long. Okay, so we were given all these points and we were asked to prove that angle ABC, I'll mark these in green, is congruent to angle DEF. We're asked to prove that these are congruent. Well, I have no way to prove they're congruent unless I know the whole triangle is congruent. So I could use SSS. I'm going to need the distance formula to use SSS. This is going to be very long. So basically what I'm going to be doing is finding the distance of everything. So like the distance of segment AB. And then I'm going to find the distance of segment B, I never labeled it, BC. And then I'm going to find the distance of segment CA. Okay, so I'll do one of these for you. AB, the distance for AB is going to be x2 minus x1. So I'm just looking at the coordinates AB. 5 minus 2 squared plus -1 minus 3 squared, which equals the square root of 3 squared, which is 9, plus -1 minus 3 is -4 squared, which is 16, and the square root of 25 is 5. So AB is 5 units. I'm going to pause the video and do the rest of these distance formulas for you guys so you can see, but it's a lot of work. Okay, so here's all my lengths of every side of these triangles. So AB came out as 5, and so did DE. DE was 5, and then BC was radical 17, and EF was radical 17. So let's make some congruent tick marks here. I got 2 here. And then AC was radical 10, and DF is radical 10. And so I'll put 3 tick marks on this one. And so the triangles are congruent by SSS, like I tried to prove. And now I can say anything's congruent. So we can prove that angle that we wanted to prove, that angle ABC is congruent to angle DEF by CPCTC.